Okay, so we're working through the Unit 2 calculated load paper from summer 2017, and we've reached question 12. So we're into the C's and marching towards the grade B's. Another question that they like is where they're expecting you to form an equation out of some geometrical shape. So we've got a triangle, so we know that those angles should add up to 180. Which means that I'm going to start by writing down that angle, and if I add it to this angle and then add it to that angle, then those angles have to add up to 180 because that's the property of any triangle. Then I can tidy that equation up because I've got a 3x plus a 2x is 5x plus a 5x makes 10x. Then the number part on the left hand side, I'm at negative 2, I'm adding 1, negative 1, and then I'm taking off 9, so I'm going from negative 1 down 9, I end up at minus 10. That must equal 180. So now we're just solving a straightforward equation where first of all, I need to get rid of the 10. I do that by adding 10. If I add 10 to one side, I've got to add it to the other as well, which leaves me 10x on the left-hand side equals 190 on the right-hand side. To get the 10 on its own, I've got to divide by 10. So to get the x on its own, I've got to divide by 10, which means I have to divide the other side by 10 as well, meaning that x is 19. So x is 19 degrees. Now, does that answer the question? Show that the triangle below is not a right angle triangle. Doesn't answer the question. Just tells me what x is. So to work out what whether there's a right angle in there, I need to now work out what each of these is going to be. So this one is going to be 3, and instead of x, bracket 19, take away 2. So I'm replacing the x with 19 because I know what it is. If you want to do that in your calculator because you don't like your 19 times table, it goes in exactly as we've written it. So 3, 19 take away 2 is 55. So that angle there is 55 degrees. This one, 5 bracket 19 take away 9. So 5 bracket 19 take away 9, 86. So that's not a right angle. And finally this one, 2 bracket 19 add 1. Do that one in my head, 38, 39 degrees. So that's 55, that's 86, this is 39. So it's not a right angle triangle. So no angles are 90 degrees. So there's 5 marks for that. There's 3 marks for actually solving the equation. So 1 mark for writing that line of algebra. 1 mark for getting it down to the 10x equals 190. And 1 mark for 19 degrees. And then 1 mark for figuring out the angles and concluding that none of them work out to be 90 degrees. Question 13. Trial and improvement. This should be easy marks, but lots of people throw marks away. A solution to the equation x cubed minus 2x minus 5 equals 0 lies between 3 and 4. Use the method of trial and improvement to find this solution correct to 1 decimal place. So we start in the middle. So x is 3.5. We're replacing the x, so we're going to have brackets 3.5 cubed minus 2 bracket 3.5 minus 45. And we work out what that is. So 3.5 close bracket cubed button, take 2 bracket 3.5 take 45. Press equals. You get negative 73 over 8, or minus 9.125. Now what you're looking for is a value of 0. That's negative, so it's too small. So we know it's negative, so all we need to do is say that's too small. Now, because we know this lies between 3 and 4, and 3.5 is too small, it means there's no point trying 3.2 or 3.3, because they're going to be too small as well. So we're now looking, we know we're homing in between 3.5 and 4. So let's try x equals 3.7. And figure out what that's going to be. So bracket 3.7 cubed minus 2 bracket 3.7 minus 45. So that's still negative. So it's too small. So there's no point with 3.6, so we'll try 3.8. Open bracket, 3.8 cubed. And we've got a positive. So 2.272, so that's too big. So I know that 3.7 is too small, and I know that 3.8 is too big. These are consecutive, so because we're counting up in 1 decimal places, we want that to happen. We want to get consecutive 1 decimal place numbers, 1 too small, 1 too big. So this means x equals 3.7 or x equals 3.8 is my answer to 1 dp. We've just got to decide now which one of these it is. So we have to go halfway again to test it. So we say test halfway between 3.7 and 3.8. If you're not sure, just think, well, what would be halfway between £3.70 and £3.80? £3.75. So halfway 3.75. So we're going back into our calculator and doing 3.75 cubed and seeing what that gives us. And it gives us a positive value, 0.234, which is too big. Now, how does that help us? Well, if you think about a number line, what we're doing here is saying 3.7 or 3.8 is my answer. And halfway between there is 3.75. 3.75 is too big, which means everything that side is also too big. Any value on this side between 3.7 and 3.75 is going to round to 3.7. So because that is too big, the smaller of the two values is my answer. So if I'd have tested 3.75 and it came out to be negative, too small, I'd be saying, well, everything that side is too small, so the bigger value is my answer. So marks for that. There's 1 mark for any value that you put in and work out the correct answer once. There's 1 mark if you get another one which is between So you've either got 3.7 or 3.8. But then, in order to get the last 2 marks, you've got to do this test by going halfway and correctly concluding that because that's too big, it's the smaller answer. Okay?
Yeah.
So that should be easy 4 marks. Question 14. Right, we're into the second half of the intermediate tier and we're expecting trig and or Pythagoras. And in order to have that, we need to have a right angle triangle. This question, the only angle information they're giving me is it's a right angle, and they don't want me to find an angle, they want me to find a missing length. It's the first right angle triangle question on the paper, so it's more likely to be Pythag than trig, and it is. So it's going to be Pythag, which means I know I've got to square my sides. So I'm going to do 16.9 squared, which is 285.61. I know I've got to do 6.5 squared, which is 42.25. Then I've got to decide what I'm going to do with those numbers. Am I going to add them, which will give me a bigger value, or subtract them to get a smaller value? If we look at the question, the biggest side, the hypotenuse, is always pointed at by the arrow you make out of the right angle. So that's my bigger side, I know it. So I'm not going to add these because I'm going to want a shorter side. So I'm going to take those away. Remember, it's a calculator allowed paper, so even though I've written it like that, I'm not going to do that without a calculator. So 285.61 take away 42.25 is 243.36. Now that value is massive in the context of the question. Yeah, in the context of the question, that's 6 point something, that's 16.9. That can't be my final answer because it's 243. Oh no, I've got to do the opposite now of squaring to get back to the lengths. So now I've got to square root to get that answer. So square root, and if you press the ants button, it just takes the previous thing. So that is 15.6 centimeters. So you're spotting, I know 2 sides, they're asking me for another. I've got to square both things, then decide am I adding or subtracting, then remember to square root. So you've got a method mark for squaring and subtracting, an answer mark for the square root of 243.36, and an answer mark of 15.6. Question 15. Oh, is this going to fit on the screen? Just about. Construct. That means I can't use that. Construct an accurate drawing of triangle ABC where AB is 7 centimeters, ABC is 90, ABC is 90, and BAC is 60. Use only a ruler and a pair of compasses. You must show your construction arcs. Okay, so let's do a little sketch just to make sure that we're happy what I'm trying to do here. So there's A, there's B. Angle ABC is to go from A to B to C, and that's 90. So I'm going to be drawing something that looks like that. And then B to A to C is 60. So my triangle needs to end up looking like that. I'm not given any lengths of the sides BC and AC. So it means I can only use that. Let's do the 60 first of all. That's the easiest one to remember. So you take your compass, you open the compass, it doesn't matter how far, and you draw part of a circle. You put a point at A, because that's where I want the 60-degree angle to come from. Then, well, what else can I do? The only thing I can do is move my compass point to there and draw another little circle, because all these constructions are to do with overlapping parts of circles. So that is the first part. Now, I don't know where on that line 90 degree C is going to be, so I'm going to send that up my page. I know C is on there somewhere. I can check now that this is 60 degrees because this is in my pencil case. You're not prevented from taking it in, and I can see it's 60 degrees. So I'm feeling good. I've got at least one mark already. Then we come to the harder construction, just because you've got to do two things. You've got to bisect 180 degrees. So we have to extend the 180 degree line, and then to bisect it, put the compass point on B and mark both sides of B like that. This is the only one where you then change the size of your compass. You make your compass larger and then put the compass point on the first cross we did, and then to the second, and then when we join B through that, that gives me my 90 degrees, and where the two lines cross is C. So I don't think you're going to get one of those, because you had a construction in the paper one that you did on Tuesday. So there's one mark for the 60-degree construction and 2 marks for the 90 because it's more work. Okay, so you can play with that in your own time. Question 16. Back to right angle triangles. Well, I'm going to be surprised if this is a Pythag, because they've already tested that. So calculate the length of the side QR in the triangle PQR shown below. Oh, so now they're giving me an angle. So I'm thinking trig. Okay, right angle triangle. They want the missing side, and I know an angle. The first thing you have to do is name your sides. The right angle box points at the hypotenuse. That's what we call H. The angle that we're using or trying to find points to the opposite, and the thing that's left is the adjacent. Once we've labelled our sides, we then go, in case we've forgotten them, we go back to our formula sheet where we've put these in, and you need to select the correct trig ratio, John, this time.
All right.
So I need the O in it because it's the side I'm trying to find, and I need the A in it because it's what I'm given. So the one that links O and A is TOA. So let's write that over there so that we can put the formula page away. So that's what I'm going to use. You then cover up what you're trying to find. I'm trying to find the opposite, which is O, and the T and the A on the same level, so they're joined by a times. So the opposite is, don't know why I'm suddenly writing in red, tan, and tan is always linked to the angle, times the adjacent. So opposite, which is what we're trying to find, which is QR, equals tan 24 times A, which is 18. Then you come to your calculator. Now then, on the morning of the exam, I will come in and make sure you've all got this right. Sometimes, especially if you borrow a calculator, it's in the wrong mode. Okay, so I did this before the numeracy paper. I came in and I asked you to type into your calculator sine 30, press equals, and then I said, do you all have a half? And if you didn't have a half, 0.5 is fine, then it means your calculator is in the wrong mode. So mine there is in the wrong mode because sine 30 is not giving me a half. So what I then have to do is go to setup, so shift mode, and change it to degrees. And now when I do sine 90, sorry, sine 30, I get a half. So I know now I'm going to do it right. But I'll do that with you on the morning of the exam. So tan 24, when you press tan, it automatically opens up a bracket. You have to remember to close it. Then times 18. So 8.014. They've given their length to no decimal places, so you could write it as 8 and it would be fine. You could write it as 8.0, you could write the whole thing out. Because it's not telling you to give it to a particular accuracy, that's fine. So for that one, there's 1 mark for the correct trig arrangement. There's 1 mark for having it the right way around, so tan 24 times 18, and there's 1 mark for 8 or 8.0 or 8.01. So that's lovely as trig questions go, because there's no context and it's just nothing to untangle. So that's question 16. Question 17. Again, this came up on Tuesday, so it's unlikely to come up next week, but we'll work through it anyway. 100 boxes each contain 10 balls. 45 of the boxes are labelled A. They each contain 7 black and 3 white. 25 are labelled B. They each contain 4 black and 6 white. The rest are labelled C. They each contain 8 black and 2 white. In a game, a player chooses a box at random and then chooses a ball at random from the box. So here's our choice of box, either box A, B or C. The branches have to add up to 1. So by doing 1, take away 0.25, take away 0.45, that means that that missing branch has got a probability of 0.3. Then in this question, they've filled in the second one for us already. So what is the probability that a player will select a black ball? When we travel along a tree diagram, we're using the words and or when it comes to probability. You need to remember that and means multiply in probability and or means you're going to add. So to get a black ball, I could be going A and black, or I could be going B and black. Or I could be going C and black. So each of these ands is a multiplication. So A and black is 0.45 times 0.7. The or is an add. B and black will be 0.25 Sorry, gone off the thing. So, or B 0.25 and times black 0.4, or probability C and black 0.3 times 0.8. So when I'm using the word and, I'm multiplying. When I'm using the word or, I'm adding. It's up to you what you do here. You can work each of those out separately, or use brackets and do it as one great big sum. So 0.45 times 0.7, or, open bracket, 0.25, 0.4. I'm typing in point there. You could have put the noughts in, it doesn't matter. Or 0.3, just prove it, times 0.8. So the probability of you selecting a black ball is 0.655. That's part A and part B. I think there's a part C to this one. Yes. If a large number of people who play in the game, approximately what fraction of them would you expect to choose a white ball? Now, the risk, well, not the risk, one way of doing this would be to work it all out again, except going A and white, B and white. But you don't have to do that, because the total probability adds up to 1. And you're either going to have a black or a white. So all you actually need to do here is 1 take away your 0.655. And your calculator turns it into 69 out of 200, which is 0.345. So 1 over 10 is 0.1. So that one's 0.1. 1/5. So if you want to do this on your calculator, you could put it in 1 over 5 equals SD 0.2, but I know it anyway. That one's 0.25, and a third is 0.333 recurring, and a half is 0.5. So which one is closest to that? 1/3. Right, marks for that paper, that question. Where's it gone? I lost the question. So 1 mark for part A, 3 marks for part B, and the 3 marks are 4. There's 1 mark for any of those multiplications, any one of them, and then there's a method mark for adding all 3 together, and answer mark for the 0.655. And then for part C, there's 1 mark for correctly figuring out that. Okay, we're nearly there. No, I lied. Question 18, some algebra. Factorize. There's your trigger word. Factorize means put into brackets. So you're looking for common parts to each part of the expression. So x cubed, I could write as x times x times x minus 5x. So I can see that I've got an x common to both. So I can take out that x. If I take out an x, I'm left with xx in the first one, which is x squared, minus 5 in the second part. Check you're right. X times x squared, you should know, is x cubed. X times minus 5, minus 5x. When we've got double brackets, expand means get rid of the brackets, so we're multiplying out, and simplify means we then got to tidy it up if we can. When we're multiplying out brackets, everything in the first bracket has to be multiplied by everything in the second. So we have to do 2x times x to get 2x squared. We have to do 2x times 4 to get plus 8x. Then I stop multiplying with the 2x because I've done it. So now I've got to come to this negative 3. I've got to do negative 3 times x, which is negative 3x. And 3 times 4 is 12. Negative times a plus. The signs are different. The answer is negative. So that is the expand bit of it. The and simplify bit is, well, I've got 2x terms. I've got an 8x and a take 3x. So I can simplify those to get plus 5x. Because I'm at 8 on my number line and I'm moving down 3. So this, the sign thing, where it's plus times a plus, minus times a minus, that only comes in when we're getting rid of the brackets, when we're actually multiplying. And then we did a bit of practice of this a few weeks ago. When you're asked to factorize this, this is a very specific type of algebra. It's called a quadratic, because it's got an x squared term, an x and a number. And the method I showed you, but you've probably forgotten, is you list your factor pairs of the end number, which are 1 and 28, did this earlier, 2 and 14, 3 doesn't go in, 4 does, and 7 repeats it. So I'm looking for a possible pair there, so I'm only looking at the ones that multiply together, that can combine to end up getting negative 3. There's no way I can get negative 3 out of 1 and 28. There's no way I can get it out of 2 and 14, but I could get it out of 4 and 7. So this type of equation, x squared, x and a number, always ends up in double brackets. It's the opposite of what we've done in part B. And I know that the number parts are going to be 4 and 7, but I've got to make them add up to come to negative 3. If they were both negative, I'd end up at negative 11. If they were both positive, I'd end up at 11. If the 7 was positive and the 4 was negative, I'd end up at 3. So to get to minus 3, I want add 4, take 7. Okay, it doesn't take long to practice that, and certainly in my classes we did have a go at a few of those, so you've got some. Yeah, we did. No, you're probably asleep, but we did, and you liked them. Okay, so marks for that. 1 mark for the factorize. Then, so that factorize there is probably grade C, but this is grade B for expanding that bracket, and then for this bit, 18C, 1 mark if you got the 4 and the 7, and 1 mark if you got the signs correct. Question 19, we haven't done this. Equation of a line is horrible. So you just have to bear with me with this one. Guess them. What you need to do is get the y on its own. Okay, so what you're comparing with is this one is going to be, so you divide by 3. So you get y equals 2 divided by 3x plus 6 divided by 3. And you're looking for which one here has got this part of it the same. That's the steepness, the gradient. And if they're parallel, the gradients are the same. So if I take that one and I divide by 3, I get the same thing. I get y equals 2 over 3x plus 7. Those bits are the same, which means that's the answer. Oh god, this is even worse.
I get it. Okay.
Circle the equation of a straight line that is perpendicular to the line 5x. So we're in now to high grade B, okay, because this is AS maths to a certain extent. If lines are perpendicular to each other, their gradients, when you multiply them, become -1. Okay? So you're looking for two things that end up with -1. So that one's 5, that one's 1 over 5. 5 times 1 over 5 is 1, so it's not that one. That would be 5 times 5 is 25, it's not that one. So that would be 1 over 5. What have I done here? 5 times 1 over 5 is 1. 5 what did I say? -1, isn't it? 5 times that. 5 times 5 is 25, it's not that one. 5 times 5 is 25, it's not that one. 5 times -5 is -25. 5 times this one, -1 over 5 equals -1. It's that one.
So it always adds up to minus.
They'll multiply together to give -1 if they are perpendicular to each other. So that's bonkers.
Just guessing.
Yeah, that's very much there for the higher tier. We did practice circle theorems though, because whereas that's a lot of maths to even answer those small questions, circle theorems are quite nice if you like angle properties. And this one is probably the easiest of all to spot, where you've got this arrowhead idea. And what this one tells you is that whatever the angle at the circumference is, the centre is double it. So if that's 37, that angle there is 74. But before we get excited, let's read the question. Calculate the size of the reflex angle. Okay, so that's a trigger word there. It's one that we introduce in sort of year 7 or year 8 and then forget all about. A reflex angle is bigger than 180 degrees. I've found there the inside angle is 74. The reflex angle is actually that one. So AOB, the interior is 74. The reflex is going to be 360 degrees in a circle. Take away 74. So that's 286 degrees.
That's it.
That's it? Yeah. So a method mark there for, hang on. So you get 1 mark if I see 74, 2 marks for taking it away from 360, and for those horrible ones up there, 1 mark each. So then we come to the very last question on the paper. The area of triangle ABCD shown in the diagram below is 35 square centimeters. So that area there is 35. AD is 5 and BC is 32. DC is on the line AC and BD is perpendicular, so I've got a little right angle going on in there. Calculate the size of angle X. So angle X is inside a right angle triangle. So life's always easier to look at what I've got. So I've got here D, B, C. That's 32, and I want to find that angle there. So it's going to be trig. But in order to use trig, I need another side if I'm trying to find an angle. So I haven't got enough information yet from there. But I've got this common side BD, which is also inside this triangle, ADB. And I know the area of that, I know that is 5, and I know the area is 35. And I know how to deal with areas of triangles, because an area of a triangle is half the area of that rectangle. So the area of that rectangle is going to be 70. So 5 times something is 70. So if I do 70 divided by 5, I get 14. So that side is 14 centimetres. And if that's 14 centimetres, I now know over there that that's 14 centimetres. Now this is the last question on the paper, okay, so it's challenging. We're in trig, so I know I got to label my sides. The right angled box points to the hypotenuse. The angle that I'm either going to use or need to find gives me the opposite, and what's left gives me the adjacent. Then I go back to my little trig boxes. I'm looking for the one that links A and H. So the one that links A and H, and there's only one of them, is the K. Okay, so K. So let's write that down. C-A-H. Now when you're trying to find the angle, it's the letter you cover up. The angle is always linked to the sine, the cos, or the tan. So cos of the angle, cos of x, is A over H. Put in what we know. I know that A is 14 and H is 32. And to get the x on its own, I've got to do the opposite of cosing. Now if you look on your calculator, the opposite of cosing is above it, and it says cos minus 1. So we write this like that. And then we can type that exactly on our calculator as I've written it. Shift cos to get the cos minus 1. Fraction button, 14 over 32, close the bracket, equals 64 degrees. Or 64.1, doesn't matter. Okay? So there's 5 marks for that. When you have horrible combined triangles like that, separate them out. Draw yourself an extra couple of triangles. So, marks for that. There's a method mark and an answer mark for just getting the 14 centimetres, so not even using trig. And then bringing the 14 into there. There's a method mark for cos x is 14 over 32. A method mark for knowing we're going to invert it, and an answer mark for 64 degrees. So chances are if you've got your full marks there, you might be doing the wrong paper and you should have been doing higher tier instead.
Yeah, that's me.
Yeah, right.